Hi everyone. Today we're going to discuss one of the applications of probability. We're going to discuss decision making. So should I do something or should I not? So Sid has decided that her and Sarah are going to play a game. Sarah picks one of those three cards out of this hat. If the card's greater than 2, she gets 3 points. Otherwise, she loses 2 points. Is it a fair game? We have to figure that out. So we're going to use expected value to figure out, is Sarah going to be a winner or a loser after many trials? So first our events. Sarah's going to lose 2 points if it's a 1 or a 2. And if the card's greater than a 2, so if a card's a 3, Sarah gets 3 points. So the probability of her losing is 2 options out of 3, and the probability of her winning is 1 option out of 3. So let's put that in the expected value formula. So she gets 3 points 1/3 of the time, and she loses 2 points 2/3 of the time. Now if we add them up, we get negative 1/3. So it's expected that Sarah will lose 1/3 of a point per game. She's either going to win 3 or lose 2, but on average, she should expect that every time she plays, she will lose another third. So, not fair. Not a fair game for Sarah. Sarah probably shouldn't play this game because she's expected to lose if she repeats many, 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 many trials. So, we can make this game fair by taking our unfair game and adjusting either a probability or we can adjust the points to see and make the expected value 0. And we're going to learn that expected value equals 0 means the game is fair. So what I did here is I gave her an extra point, so she gets 4 points if the card's a 3. So then the expected value becomes 0, and now the game is fair. So if she gets a 3, she gets 4 points. If she gets a 1 or a 2, she loses 2 points. That game is balanced, it's fair. So probability is a great tool for using to make decisions. We can use simple probabilities. So what's the probability of a single event happening? What's expected to happen over many trials? We could also use expected value to compare and figure out what the best option is. Or we can use probability distributions to figure out the probability of a specific outcome or all outcomes. And we're going to see each example in action. And a game is fair if the expected value is 0. Okay, most times something's not fair. It's fair only if we expect it to be balanced on both sides. So I get to play a game with my siblings. I win about 80% of the time. I'm older. I'm better at games. I'm also very humble. So I got to figure out which option is better for me. So I can play the game and I can get $3 per win and I lose $7 if I lose. Or I can get $5 if I win, but then I'd lose $14 if I lose. So in each case, I have to find the expected value. I want the higher expected value for me. So those are the options. The probabilities, I win 80%, lose 20% of the time. Probabilities have not changed. The game doesn't change. Only thing is changing is my winning or losing. Then I could figure out the expected value of each case by multiplying and adding in both cases. And option 2 here shows me that I expect to win $1.20 per game. And option 1, I expect to win $1 per game. So both games are good for me because I have a positive expected value. So I'm expected to win in both games. But the decision I can make here is option 2 makes me more money. So that would be the option I pick. And that's one of the uses of expected value in decision making.